Hello, everyone. Thanks for joining us this evening. It's another episode of Breaking the Silos, where we talk about DevOps, problem solving, and if you are thinking of getting started in DevOps, this particular podcast is for you. You get to share resources for you to learn about DevOps. We talk about best practices. If you have been following us since the beginning of the year, we had several sessions around how you can get started about DevOps. And today we are having another person. It's someone that we've had in the past on this particular podcast. And we got very great feedback from the community that we enjoyed him and we should bring him back. And that's why we are bringing him back today. But for today, we are coming with another dimension. We are talking about the advent of code. Basically, what it's all about is about problem solving, how you can get to see a problem and think around how you can solve it programmatically. Okay, so when we talk of advent of code, it's a series of problems given to you every day in the month of December, and you are expected to solve it anyhow you want. You are free to solve it anyhow you want. I've seen people solving it using Google Docs. Google Excel, Google Sheets rather. I've seen people using Bash script. I've seen people using PowerShell. So programming language is not the important things at this point. Just how we want to solve the problem. How do we think around solving the problem? So that's why we are here today. So we have an expert in our midst, and before we proceed, I would like to bring him on stage. And yeah, the rest. Yeah, good evening. Can you hear me?
Yeah, I can hear you. Can you hear me?
Yeah, yeah, I can hear you too. How you doing? It's evening here in Nigeria. How you doing in that side?
And we're in the same time zone at this point in time. So
Wow.
yeah,
Yeah, yeah,
that's
yeah,
it.
yeah.
Yeah,
Cool, cool. Yeah, it's nice to see you this evening again. Yeah, I think some folks that are watching us, they might not be here in the past episode that we had. So I think it will be good for you to do a kind of introduction of yourself, probably a bit of your background, where you currently work, and probably your interest or your passion for the thing you are doing. What people in the yeah, that means you lost me for a second. Can you hear me now?
yeah, I can hear you. Can you hear me?
Yeah, but you lost me for a second the other time. Wow.
Yeah,
Okay, so I was saying you should do a kind of introduction of yourself, background of you, where you currently work, and your passion for what you are doing. So I got people shouting out to you in the chat. You may want to shout out to them as well.
I love my guy. So yeah, um, my name is Jiretnan Domnan, aka Devon96 online. So wherever you see like the monitor Devon96, hopefully me. Um, and I think expert, like Rashid said, is probably cutting it way too close. I wouldn't say expert. I'd say more like I enjoy what I do. So if anyone knows me, I enjoy writing Rust. I enjoy working with backend. I enjoy doing systems stuff. So currently I'm a Rust backend engineer working for Lumitovo, based in Munich, Germany. And I write Rust on a day-to-day. And yeah, I'm here to show you how you could basically. I think everyone complains like about Rust that, oh yeah, Rust is a language that has like high barrier of entry. So I think that's probably true. The barrier of entry is a bit higher, but I think once you've come to terms with like borrow checker and like the STP collections and things like that, it basically becomes second nature. You start to think in Rust, like so you start to envision solutions in Rust. So yeah, and it's a very cool language to like model your problems. Basically. Like almost any problem you can think of, you can basically pseudocode it in Rust, at least in your head, your mind. So yeah, that's I think and yeah, I think one key thing is also the fact that I'm an ex student of That's where I rush it on. So, yeah.
All right. I need to confirm again. I don't know what's happening to my network. I need to confirm whether you can still hear me. Let's do the Nigerian pattern.
Yeah, I can hear you.
You can hear me, right? Okay, yeah, that's cool. So thank you so much for that beautiful introduction. I think I personally have tried to learn about ROS and I've been able to work with it. Ah, God, I'm very sorry. That's network. I was off completely, but I think I've been able to resolve that. That should not happen again. So, because of our time and the network that we are having issue with, I think we can jump right into what we want to achieve today. So, I will be starting by showing us what it's advent of code, and without wasting our time, we are going to start. I will be taking like 1 to 2 minutes to tell us about what advent of code is all about. And if you want to, I think it's still open for you to submit, try to get into a particular problem, solve it, and at the end of the day, get to see your score. And I think they will still add you to the dealer board if you try your best to solve them. So let's just go to their platform, which is adventofcode.com. So let me find a window to share. Okay, let me just share this window. So basically, this is the Advent of Code platform. I will be dropping the link in the chat now if you want to check it out. So it's basically where you will be able to see problem for every day of the first 25 days of the month. So you click on a particular number, which will link you to that particular what's it called? I think I'm not showing my screen. I'm not actually showing my screen. That's why. So this is the page I was trying to talk about. So you are going to see a list of the problem, and then you click on any of them. Then you can go through them. You are going to see how you can go to that, and how you can submit your problem at the end of the day. So those are the things we are going to be solving here. How to solve it, how to think about the problem, how to come up with a solution, and at the end of the day, submitting it to get into the leaderboard. And at the end of the before any other thing, if you are unable to catch up, you can check the subreddit for the advent of code. So you see a lot of people solving the same problem with different pattern and different method and different programming language. So I've wasted a lot of time. I can stop sharing at this point, and I can bring up the rates to show us. I think it would be good for us to start from day one, or what do you think?
Yeah, I think I'm on board with you on. So let me share
Okay,
my
so I'm even thinking probably we should push it to our community members, to the participants. Are they interested in any one that they want us to solve? Keep that with yours, with yourself rather. As we progress, if you have anything to suggest, drop it in the chat and you'll be able to catch up there. So I just drop a link in the chat for you to follow up and see those problems that we want to be solving. So I think you just added your screen. Yeah, you can
So
continue.
everyone see my terminal. My terminal
Yeah,
visible.
actually, I can see your terminal.
Okay, that's cool. So this is my terminal. I make use of Vim, typically to code Vim and Timo. So yeah, that's what we'll be using today. I think the first part to go about it is reading the question. So it says something is wrong with global snow production, and you've been selected to take a look. The elves have even given you a map. On its they use stars to mark the top 50 locations that are likely to be having problems. Been doing this long enough to know that to restore snow operations, you need to check all 50 stars by December 25th. Collect stars by solving puzzles. Two puzzles will be made available on each day. Okay. You try to ask why they can't just use a weather machine not powerful enough, and why they even sending you, and why your map looks mostly blank. And hang on, did you just say the sky? When you realize that the elves are already loading you into a trebuchet. As they're making the final adjustments, they discover that their calibration document, your puzzle input has been amended by a very young elf who was apparently just excited to show off her art skills. Consequently, the elves are having trouble reading the values on the documents. The newly improved calibration document consists of lines of text. Each line originally contained a specific calibration value that the elves now need to recover. Okay? On each line, the calibration value can be found by combining the first digit and the last digit in that order to form a single two-digit number. I think this is the first part that we start to get into, I guess, like the crux of the problem. We're given example inputs, and we're supposed to find the first digit on each line and the last digit on each line, and then that gives us a single two-digit number. Where, for example, here we probably have 12. Okay, here we would have 38. Here we would have 15, and here we just have a single number here, but it's then both the first and the last, so we end up with 77. So and then we're supposed to finally add these up together to produce 142. Okay.
Okay, cool. Can you hear me?
Yeah,
So I think, yeah, I think it makes sense for us to now look at the problem. Okay, this problem, when I first checked it out on the day 1 of December, I feel like which field can I relate this particular problem to before even thinking about, oh, how do I want to solve it? I think thinking that way could help us to get to know we want to solve it and which industry are we solving it for. That may not matter actually, but then I think it still push us more and make us think the right way. So do you have any discussion or talk you want to make around that?
I think this could be applied anywhere. To be honest, the truth is like the web or generally in programming, like almost everything is like the Wild West, right? It's very possible you are receiving inputs from like extremely unstructured data, right? And you have to extract structure out of your extremely unstructured data. So it could be that there's some semblance of the pattern you've noticed that gives you the structure you're looking for. Or basically, like the entire document itself is unstructured. And so writing these sorts of parsers that move, data from unstructured to structure is like one of the things you would do a lot as either a back-end engineer or a systems engineer, basically trying to bring out order or a semblance of order from chaos. So knowing how to do this and do this effectively would help. Um, I think typically for now we would just go for I guess simple solutions since it's also supposed to be like I guess the primer into Rust as well. But in the long run, ideally you'd want to do this and do this like very efficiently. Rust in itself is an efficient language, so you don't tend to waste a lot of memory on your services that are written in Rust. Uh, but yeah, this has a ton of applications everywhere. It has a ton of applications everywhere.
Yeah, that actually makes sense. I think in computer science class, we did data structure, structuring data, and I think we did it for like whole semester and more than that. They will say, oh, if you are studying computer science, you are talking about memory, data structure, algorithm. That's mostly what we talk about in class. So I think it makes sense. Oh, let's proceed from there. Thank you.
Okay. So first thing I'll do, I think I'll gloss over the simple fact. There's cargo, which is a Rust utility, right? I'd suggest if anyone wants to follow, they have cargo installed already and have like a Rust setup on their system. But for now, I would go under the assumption that have cargo installed. Um, but let's start with cargo new. Uh, I do want to create. Let's call this advance of code, I suppose. Uh, and then we start with. So can everyone see my screen?
Sure, sure. Your screen is up. I can see hello words.
Yeah. So is it visible? I hope it's large enough. Is the text large enough? So
Yeah, yeah, yeah. It's actually large enough, and I can make it bigger. Showing this, okay. Just showing this. Yeah, I think it's actually makes sense now.
all right then. So I guess the first part would probably go for want to outline our problem, right? So I'd say let's get our example out for input. So we know we want to do something like this, and we know this should end up with let's say 12, right? And then we have I guess plus 38, right? And plus 15 and plus 17. So this is ultimately what we're going for, right? So I think typically the way we would solve this is to first come up with our structure, right? Let's call this found digits. So there's a concept of option in Rust, right? Which means a thing can be both, can possibly be a non-variant or a some variant of a concrete type, right? So for this, we are going to make sure our first digit, this particular structure is going to host our digits that we find in a single line. So we're going to make it an option of a U32. I'm using a U32 here because they give us unsigned bits. We're not having to parse plus ones or minus eight and things like that. And besides, it's just single characters, so there's no way we could know if it's signed. That is considering a single character. So this is our basic structure. And I think the first part we'll do is to implement it, right? So we can do have our implementation, and the first part we would want to do is create some sort of parser that can go from that can basically iterate forward to find the first digits, and some other parser that can go in the reverse direction. So since we'll be doing this in both directions, I'd say the first thing we do is probably come up with some sort of utility that has that takes in the iterator itself. Uh, okay. So this might look like it's a bit strange, but yeah, I'd say we start with this. I'll explain what this means in a sec. And yeah, I think this is fine enough for us to start with, and we get back into this. So what purpose of this basically is to be able to take in. We have iterators in Rust, right? and they basically form structures that you can map, reduce, fold, collect, and do a lot of computationally interesting things with, right? Iterators are not typically held completely in memory, right? Which means as you call your dot next on an iterator, that's when the next value of the iterator is being computed. So the entire iterator is not, or the entire underlying structure in the iterator is not held in memory, right? Which is fine for us and it's our goal because we want to move across it character by character. So, and that's why we're passing in an iterator, yeah, right? And then we just basically evaluate that particular iterator and we return, u-tests that we found. I hope that makes sense. Is there any confusion? Like I really can't see the chat, so
Okay, yeah, yeah. Okay,
I'll
so people have not been reacting in the chat. I guess they are trying to follow along, probably being on their laptop, trying to see what's going on. They may not be able to drop things in the chat actually, but
yeah,
then
that's
I think it actually makes sense. The explanation actually it's actually straightforward enough. Yeah, I think the other parts, the part that can be like, what's this guy writing? Is that function declared? And for people that are not exposed to that kind of thing, they may be like, oh, trying to, what are you trying to do with that? And I think you did a good job by explaining what iterator means and how it works actually. Yeah. So I think if somebody is joining late, it may be like, okay, how did this guy got 1 2 3 8 1 5 1 7 and 7 7 or something like that? Okay, so it's basically the first number and the last number that we are taking out of the string given to us in the beginning. Yeah, so that's where that one is coming from. The first digit find from the left hand side and the first digit find from the right hand side. That's what we are doing. Then we are making them a single digit, which is a two-digit number. Then we are adding them together. So the one that we wrote 17, I think it should be something like
yeah, it's
77
seven,
because
seven actually. Yeah.
yeah, actually. So with that, you can add them together and be able to get something out of that. Yeah, I think it actually makes sense, and people are saying talking in the chat that oh, we are cooking something. Okay, let's continue cooking. Yeah.
Okay. So yeah, we want to have our output here. We want our output to clearly. Our output is going to be our final optional u-test that we send. But in the beginning, we've not found any character, right? So what we are going to do is now try to consume the iterator that we've sent. So to do that, we can use the while let sum syntax in Rust. Let's say found character. Let's just call it found equal to iter.next. So this basically guarantees us that we just keep iterating over the iterator while we have a next character. So if we've reached the end, this while loop is going to stop. But also we want to stop early if we say we found some output. So if output dot is sum, right? We also want to break. So meaning if we've already found like a first or the character we're looking for, we want to break as well. We don't want to continue iterating. Like that's just waste of information, right? And then what we then finally want to do is say output then be equal to found dot. So now I'm going to do one thing which is basically try to parse a string into a U32, right? And then we can see this particular function here called toDigits, which is given to us on single characters by Rust itself. I didn't write toDigits. All we have to do in toDigits is basically pass a radix. So you can see what the radix is defined. The radix here is basically, or it's sometimes called a base. So meaning if I want to convert this particular character I found to base 2, my radix is going to be 2. But obviously we're using base 10. So the radix I'm going to use is 10. Right. So a radix of 10 is decimal, a radix of 16 hexadecimal, and so on and so forth. So yeah, for this our radix is just going to be 10. and then we can say output. So this basically ends our parse with iterator function, right? So what we do want to do is create a new that takes in some inputs and gives us found digits, right? So, but then how do we construct this iterator for our first digits? We want to basically say parse with iterator, and then I want to return inputs dot cars, and that would just work for us, right? While for second, I actually want to be able to do dot cars, but remember second wants to come in the other direction, right? So cars as an iterator actually is a double-ended iterator. There's a thing called double-ended iterator, Rust, which basically just says, you can call dot reverse on it, and instead of starting from the front, it starts from the back, right? So this function is basically then going to work to while first comes from the front, second comes from the back, and then we end up finding both characters. And if we don't have both characters, we basically return, we end up with nuns in either case. I think the final thing I then want to do is then say okay, so let's have an output function that basically then returns to us optional utest2. So, but this is then going to combine both the first and the second one, right? So we can use Rust syntax like this. If let's say some first, some second, and self the first, self the second. So if we have like this, right, and we're able to wrap that. So yeah, now this syntax might look strange, but it's basically still format of whilelets. So when you have options in Rust, you can basically try to check ahead if that option contains some concrete sum type or if it's none. So in this case, in order for us to know if our found digit structure works and found at least one digit, right, there has to be a value in both first and second, right? Because you can imagine if we pass in, let's say you pass in some string A, B, C, D, E, right? We'll end up with first digits or found digits instead, and it's going to be first is going to be empty, right? And same as second, both are going to be empty. So for now, this tells us if both are sum, we want to then do something, which is we want to return first times 10 plus second. The rationale being want to return sum of first times 10 second. So now the rationale being obviously the first digits, if we found 7 as our first digit and let's say 7 as our second digit, we want to multiply this first 7 by 10 to give us 70, and then we just add the second 7 to give us 77. So that's basically how that would work. And in the case where we find, sorry?
Okay. Yeah, I think that makes sense, and we can trace that back to our place value number in elementary mathematics, where you have 100 place value, we have units. Then if you are working with tens, you need to have 2 digits, and the first digits you need to make it in a way that it is in 2 places. Okay, so When you are doing subtraction, they will tell you you are borrowing something like that. So it
Mhm.
basically place value, hundred, tens, and unit, thousand, and all of that we did in elementary mathematics. So if your elementary mathematics sucks, I think you get yourself to be blamed here actually. So I think with the explanation you'll be able to catch up from there actually. Yeah.
Mhm. Yeah, so I think we can basically just I suppose test something basic for this. So I'm adding like a derived macro here that just helps us basically print out found digits, right? To see if we are doing the right thing. So remember, this probably just works on an entry string. Let's see how this is going to work here. So this is how you would typically use your debug statement. And let's say found digits, uh, found digits. That's new. Let's take one of our inputs here. Okay, yeah. Mm, yeah, I see that's output. So we'll see if we're doing the correct thing. And we call that advent, right? Okay. So let's say single cargo run. So yeah, we have this here, right? Sum 12. So meaning we're on the right track. There's some things we're being warned about, which you can remove the surrounding parentheses. And yeah, they will stop yelling at us. So let's do that and make the compiler happy basically. So
Okay,
if we run
cool. After fixing that, yeah, I think we were able to get two digits from that. I want to suggest we should try using a two empty a list of a string that does not contain any, yeah, that does not contain any digits. Yeah, let's see what we have from there.
so now we
Can
can
we have
see,
one? Yeah.
yeah, now we're fine. We're doing exactly what we should. We have none, a case where we have no digits, and we have some. Let's try the case where we did have just one digit. Let's see if we correctly get the 77, right? Okay,
Yeah.
so it works. And now the next part we want to do is then say, so now we're giving this entire thing as a whole string on its own, right? Um, but then obviously it's split by new lines. So we want to treat each string or each line independently, passing it into found digits, and then at the end we basically collapse the entire iterator in some sort of reduce method. But I'd explain what I mean. So we basically would get this back. Our first step would be to split by new lines. Then our next step would be to create found digits from each line, uh, get outputs from every found digit, yeah, and then finally sum across found digits. So that should basically, lead us where we want to go, right? Um, so yeah, I would say let's call this and let's say create found. Oh no, parse all lines. So we get our inputs, and what we want to return back is some U32, right? Let's assume we are okay, yeah, we're returning back a U32, and we want this to be able to let's get rid of two of these, and then say, and we don't need this. Instead, we can say we just want to parse all lines, right? And then we can, yeah, do this. So let me copy this. Right. So we want to parse all lines. This is still yelling at us because we've not implemented it yet, right? But what we do want to do is say so input dot split. We want to split by new lines. And after we do split, we want to map across that. And let's say we call it line. We then want to say found digits, new line, right? And then yeah. So now what we want to do next is called flat map. So the reason why we use flat map here instead of
Flatten.
map is basically because we want to flatten out the nons. So remember previously we had sum 12, and whenever we didn't find something we had none. Those cases. So we want to get rid of all those nons because they don't make any sense to us. It means we got jargon input. So that's one way of error handling in Rust, which is basically just ignore these errors with option. The other way is to have result types, which basically give you some concretity and some error. So yeah, for this would say we have found digits, and we just say found digits the output. Right. And then what we then finally get, so now we've basically flattened out all the outputs, right? We should only have sums in there. The next thing we would probably then want to do is to be able to accumulate basically everything together, right? I don't know if that makes sense. Are you guys following with me?
Sure, we are with you 100%. Okay, so the point you are trying to make here is okay. What we want to achieve at this point is we want to pass all, and what we mean by passing all is okay. We want to get for each line. We know that our input will not just be a single string; it's a multiple string. So, and these strings are being divided with a new line, and that's what we are using to split and get each string done. And when we get two digits from every lines of this string provided or input provided, we want to combine them together and do the addition and finally have the results. And explaining the flat map, it's actually to remove the nons and just a basic way of handling errors. I think that actually makes sense to me, and I believe it will make sense to the audience as well. Yeah.
Okay, so the next thing we'll go for is a reduce statement. So what a reduce effectively supposed to do is taking each of those flat maps and add it to some sort of accumulator, as we call it, right? So in this case, all we do want to do is just say accumulator plus the new variant. That's what we want. And then, but because what reduce gives us is an option, as opposed to because it's coming from a map, it gives us an option as opposed to the concrete value. So we want to do an unwrap or default instead here. So you can see the type of this line is an optional utext.
And then the option was created in the first place.
Sorry?
Said it's relying on the option that we created that we are running on. Is that true?
No. So whenever you run a dot reduce on your particular structure, you get an option of that type.
Oh, makes sense.
Yeah. You get an option of the final concrete accumulator type. So in this case, we unwrap or default, which means if it was none, this would actually turn into a zero, which is fine because it then means we didn't find any number on any lines, and so zero, which is fine. But in this case, then in this other case, we're going to actually accumulate each and every one of them. So let's test and see if this works. Um,
Yeah, and if we are getting zero with the calculation I want to do at the end of the day, it will still make sense because if you add zero to anything that we have, to still not have effect on the general
exactly.
result that we want to have. Yeah, makes sense.
So now we ended up with a 142, and that should be correct if I'm right. Let's see if that's correct. So we ended up with a 142. So let's get rid of one of these lines, right? Let's see. So 127, yeah. So now we just have a 77 and a 12,
And
which is
12
9. So
around,
yeah,
yeah, it's 9.
so it works and it does precisely what we want to do, and that should be it. Like this is your entire solution, right? So
Oh,
yeah,
yeah.
Rust has powerful iterators, right? I think when I first came into Luminovo, I wrote Rust very I guess in a very procedural way, right? But then I realized that Rust has heavy support for iterators. I'm just working with other people who've written Rust and like having people review your code over time. You get to discover that Rust has powerful iterators, and taking advantage of those iterators just basically um eliminates a lot of the things you do want to do whenever you have like some sort of array type structure, some structure that you're iterating over, has been covered by a lot of like the methods on these iterators already. So they give you like flat map, reduce, you get to fold stuff, you get to collect into different types of structures and things like that. So yeah, it's extremely powerful. I suggest that anyone who writes Rush should basically always just look into the iterators and like standard library for them.
Yeah, actually makes sense. I think when I was trying to practice with it and try to get something done, though I don't have as much as code as this, but then I tried to figure out how powerful and a lot of things that are built into Rust that can get things done for me very easily than any other programming language. I think it actually makes sense and it's cool. So I don't know if you can take a minute or two to do a kind of rundown of everything. And I have people in the chat saying, is it because I joined late? I cannot catch up and all of that. So it will be
Okay, I
good to have a kind of rundown for them and starting from the problem statement and showing them how we come up with the
yeah. So I'd condense the problem statement like this. We're going to be giving inputs that looks like this. We're effectively supposed to, on every line of this input, get the first digit and the last digit and use it to form a 2-digit number, right? So in this particular case, the first digit is 1, second or the last digit is 2. So our number is 12. Here the first digit is 3, the last digit is 8, so we have a 38. Same goes here, we have a 15. And here where we have just one digit, it's both simultaneously the first and the last. So our number is 77. So how did we go about solving this, right? First thing we had to do was come up with our structure called found digits. So found digits basically keeps track of first digits and second digit. I guess we could have as well called this second one last. So I just refactored that. So it keeps track of our first and our last digits, right? So both of them are optional U32s. So the reason why you always put some semblance of thought into like the types you pick. It's unsigned because we weren't given any specification that would be looking at negative numbers, right? And because we're looking at single characters, how then can you encode negative numbers using like single characters? So they are unsigned characters, and we're going to go for like the lowest possible one, which is U32, right? Same goes for the last as well. They're both just options of U32. And options, basically, as I explained, either none or some concrete T type. In this case, the T is U32. Then the first thing we did was come up with an underlying parse function that basically takes in an iterator. So this particular structure called an iterator in Rust is a memory efficient way to iterate over a structure without having to load everything in memory first, right? So that means basically every time I call .next on this particular line, it just evaluates the next entry in the iterator. So I want to get an iterator. I keep track of my output. My output is an optional U32. I initialize it to none, and then I basically go over the iterator, and I first check if I've already found some outputs. Right, there's no need of continuing, so I just break out of that loop. Otherwise, I basically say output equals to found. So 2 digits is a method given to me by Rust on a single character that turns that character into an actual digit. Because remember now we're dealing with car, but I want to make it a U32. So I can't just say output equal to found. I have to do output equals to found 2 digits. And radix just basically means the base. So we're going with base 10, we're not going with base 2. We're not trying to turn it into base 2, we're not trying to turn it into hexadecimal. So the radix of this is 10. And then I just output, send my output. In Rust, you don't need return statements on your final data structure. You can just put the data structure there, except you are eagerly returning, like in this case where we had iflets. We're doing some sort of eager return here. So that's for the parse with iterator. So then how do we use this parse with iterator, right? We basically use it here whenever we receive like the original input string. I want to call parse with iterator to get first digits, and I do input.parse, which basically is a character iterator over an input. But then parse is the double-ended iterator, which means parse can also start iterating from like the last character upwards instead of like first character downwards. And how do you do that? You just call .rev, which is .reverse on the iterator, and that's what I use for last. So this starts iterating from the front, this starts iterating from the back, and anytime they find some character that is a digit and they parse it, they just stop. And then finally what I did was have an output function which basically checks if both first and last are set. If they are set, I return first times 10 plus last. And the reason being obviously from our basic primary school math, right? This is like 10 decimal places. You have your hundreds, you have your thousands, and so on. We know we're dealing with 2 digits, so this is just times 10, right? And then if both of them are not sum, then we return none. So option is basically a way to handle errors in Rust without basically explicitly erroring. So if we wanted a case where it's possible for us to find the first digit and we didn't find some last digits, which is not possible in this case, because if we have even just a single digit, it's both the first and the last. But if there was a possibility, right, that wanted at least 2 distinct digits, for instance, right, it would then make sense to maybe have a result type here, and maybe if we wanted to throw some error in some specific case where we don't just want to ignore it, right? We would go for something other than option. And then the final thing I did was just create this parse all lines function, which what it does is it takes the inputs it splits it by new line. So basically, because we know here we have a new line separator between all these lines, right? We split by new line, and then we map over each of those splits. We turn it into a found digits new, and that new underneath does all the magic that we've created below, right? And then we call a flat map, which basically takes out all the nonce. So we call found digit dot output, which can give us a sum or a none. And for all those ones that give us a none, we would basically just ignore them. And we can prove that here by, let's say, adding A, B, C, D, E, F, G, for instance, right? We should still potentially get 142.
142. Yeah.
Yeah. So it basically ignores all the nonce. Um, and then this reduce basically is keeping an accumulator and reducing your entire map structure into just a single value, in this case, which is the U32 we are looking for. So for all those found digits that were sum, we basically add their values to the accumulator, and then underneath it condenses it. It just calls the next and then adds accumulator plus E, calls the next, adds accumulator plus E, and assigns it to this accumulator here. Or let's just call this found output, so it's not so crazy. So yeah, and then finally, because reduce gives us an option of T, right? Where T is your type of the accumulator, in this case a U32. We finally just unwrap or default, and we have our U32. So even if we had all invalid lines, for instance, we would finally just get 0, right? And that would be it. So yeah, that's the bulk
Yeah.
of this particular advent of code, I think.
Yeah, I think it actually make a lot of sense with the explanation, like with the rundown did now. For people that was unable to catch up along when we started, I think with that they should be able to see how we're able to arrive at that particular code base. And yeah, I think we'll be making the code available for them as well if they want to check it
Yeah,
out
sure.
and play around with it. Yeah, one thing that we've not done is there is this puzzle created by the Advent of Code team for individual person participating in Advent of Code. Then we can get that. If you scroll down to okay, are you logged in? You can log in with your anything that you wish to log in with. So they will attach a kind of puzzle to your account. Then you can get that input, and then with that you can submit your solution, and yeah, you get to be ranked on the leaderboard. And I think that's all about Advent of Code. Solve the problem, submit it, the solution is right, and then you get to be featured on the leaderboard actually. So I was checking this chat before. Let me go back to the chat. Currently
So
I
do we have
only
like
have,
any questions or?
yeah, I only have people shouting out saying excellent. Feel like yes, okay. Some people are saying, "Oh, the Ross you are using look like JS," trying to explain it to somebody else. And some people are saying, "Why are we using Vim? Why not VS Code and all?" So I think all those ones are just back to your interest. Once it works for you, yeah, you are good with it. Then continue using it. Yeah, that's it actually. Or do you have anything to say around the choice of editor, or why you should use VS Code, why you should use Vim or
Uh,
Notepad?
I mean, not not particularly, right? I think it's workflow that works for you. Yeah. The choice of language even ultimately is not much of a big deal. Although I personally always try my best to piss like JavaScript and Python developers off. But yeah, ultimately it doesn't. It really doesn't matter. You can solve this in any language, right? Although that doesn't mean like generally your choice of language doesn't matter, because depending on what you want to accomplish, right? It could be your underlying language, JavaScript would be best in that situation. Or if you want to do something that is very memory intensive and you want to keep like a light memory footprint, you probably want to opt in for C or Rust, right? So it all depends on use cases. Yeah, it all depends on use cases and how exactly you would, um, what exactly is your problem, basically. Right? That's
All
what it
right.
boils.
Actually, that actually makes sense. Okay, so the problem you are solving will actually determine the programming language you want to use, or even your choice of editor or whatever thing you want to do. Yeah,
Oh no,
that's why they said.
I just like Vim. That one has nothing to do with the problem can be solved in anything. I particularly just like Vim. Yeah.
Exactly, exactly. So that's why the word it depends is actually for getting popularity in the community when they say, "Oh, why are you using this? Why should I use this instead of this?" So you tell them it actually
Yeah.
depends on the choice, on your choice, on or the problem you are solving, and many other reasons like that. So because of our time, I have somebody asking question in the chat. He said he loved the approach we used to solve that. Okay, so and he's asking, or the person is asking, I think Steven, is saying, what other way can somebody take to actually solve that particular problem? Yeah, I don't know if you want to take that, but then I have something to share actually. So you can take
Okay.
it.
I think so. This question boils like there's very few diverse ways to solve this question because you have to identify like the first principles of this question. First principles being you have to split by new lines, for instance, right? Because you have to evaluate like every new line is its own entry basically, right? So you have to split by new lines. These digit characters can be anywhere within the string. They're not guaranteed that they are at some fixed index on every line, right? So you basically have to split by a new line and you basically have to search all the characters on that new line in a greedy format until you find digits. So I mean somebody else might opt in to not use, the structure or the structs that I used, right? Or the parsing method that I used to be able to do this. But ultimately you would still have to iterate over all characters in your input, basically. So yeah, in the end you get if you were to evaluate this, right, being n, where n is the number of characters in the entire string, this has to be O of n.
Yeah, yeah, I think that makes sense. And if you feel like you want to see more on how people solve this particular problem, let me just share this screen. Okay, okay, sorry. Let me just that link on the screen. Let me drop it in the chat. So you can follow it. That's solution from other community members and how they solve it with other programming language. Yeah, I saw somebody using what's it called? Google Sheets to solve a problem in one of them. So it's basically the problem solving part that we are more focused on. I think we are getting more questions and yeah, I will take them. Somebody is asking again, what will be the time and space? Okay, I think you've answered that. Very cool solution, though. So, do you want to talk more about the space efficiency and the time efficiency of this particular approach?
Yeah. So as to deal with the space complexity of this solution, right? Like it's still going to be n because basically you have to have your entire string inputs, right? We could do it in a way that you could sort of like batch this up, but that's like if you are dealing with like inputs in real time, maybe you had some platform somewhere that had to evaluate this input. Like you probably don't want to load your entire strings at once. But given this and the fact that I used Rust and I made sure to reference strings within Rust, I wasn't using like own copies of the strings, which means it didn't have to copy strings like across the board. So it just references the original string that we passed in. Right? There's no copy across the board. So you save memory that way, as opposed to a couple programming languages that would implicitly copy these strings whenever you pass into functions. So yeah, that's one way. But all in all, it's still O of n, O of n.
Yeah, and I think it's actually a good solution having a linear when we have linear time complexity and we have linear space complexity. Although it could be better, but then on a
Oh, no, space
general,
complexity is actually constant, not linear. It's like O of n, right, for time complexity, but like the space complexity is constant. Right? Like that doesn't change. It's what you're given that you get.
yeah, I think that actually makes sense. Yeah, because of our time, and I can see that we do not have any more question in the chat. I think with that we can go to the last part of our discussion. What's your advice for everyone that wants to get into how to solve problem or getting started in tech as a whole or getting started in DevOps? As we know that this particular podcast is about DevOps, we are trying to bring in problem solving. That's why we are having this session actually. So, what's your advice for everybody as a general?
So I personally don't like a lot of lead code. Uh, I don't like a lot of lead code, so I don't do a lot of lead code. But one thing I've come to realize is that problem solving basically boils down to like figuring out the first principles of like any problem. Right? So the thing is like you always ask a ton of questions whenever you're encountered with a problem, and this boils over to even like day-to-day work, right? You're encountered with like a couple problems. You don't just like jump on your terminal and start building stuff, right? Like that's going to be crazy. First thing you do is just ask like a ton of questions, stupid questions, reasonable questions. It's like just get the outlay of the problem, right? Get the constraints of the problem because ultimately we're in the computing space, right? Nothing is free. So what are the constraints of this problem? Like where does this fail over? Right? Can we have this extreme case? Can we have that extreme case, right? Once you've asked a ton of all these questions and you've basically constrained the problem to some space, right? You can go about finding some efficient way, given those constraints, to solve the problem. That's the way I see like DSA as a whole, right? So I personally haven't spent a lot of time on lead code, trying to learn some sort of Floyd cycle algorithm or niche questions. I'd say those are those would then categorize specific use cases, right? And you are better off working on like problem thinking as opposed to like cramming lead code questions and solutions.
Yeah, and if you want to try to cram all the questions on lead code, you cannot do it actually. If you
Yeah.
do it, we end up not being able to do a lot of things at the end of the day. So before we go, I would like to share the link to the what's it called? To this particular code. Yeah, oh my god. We just the rest just push it to GitHub and have it available to everybody. I'm putting it in the chat and let me make it a
Yeah,
banner as
I
well
have to get stuff right now.
so that we can. Sorry, what did you say?
Yeah, I said I'd add that to get GitHub right now.
Okay, sorry. Okay, 1 second. I'm trying to fix something. So from there they can this will take you to the profile of the rates. From there you'll be able to find the advent of codes. I can delete this one now. It's not actually correct. I don't want to drop a wrong link. So finally, what will be your final thought for us in 1 minute or something? Then we can leave this place. So your final thought for everyone, and thanks for joining everyone actually.
So I'd say Rust is a very very interesting language, right? Rust is a very interesting language, and a lot of the times people get discouraged because they hear that thing about it's like the barrier to entry is quite high, and so they get discouraged and they tap out. But the truth is, like Rust is taking over the market, and like a lot of things are going to be written in Rust going forward, right? A lot of systems are being written in Rust because of like the sweet capabilities Rust gives you and like the assurances it gives you towards like memory safety, right? Like the more we hear about like some of these crazy memory and buffer overflow type bugs, the more we realize like memory safety is a huge concern in the computing space. So definitely Rust is going to like Rust's influence is just going to grow over time, right? And so I advise people to not shy away from difficult things. I like difficulties, right? Like I like when I have challenges, else I feel bored. Right? If I had to just do crud all the days of my life, I would be bored and I would find no utility in that. But when I find difficult things that I can't do, yeah, I really can't do this, right? So it makes it interesting. And then yeah, I find some semblance of satisfaction. So yeah,
Yeah.
learn Rust. That would be my long and short.
Summarily level up. Thank you so much for joining us there this evening. And to our participants, thanks so much for joining. For those of us that have been here since the beginning and those of us that join along the line, thanks so much for joining. And this is the last podcast for this year on this particular Breaking the Silos episode. And for more announcements, if you want to get more announcements on this, try your best to subscribe to this channel. We'll be pushing out a lot of content next year, and we'll be reviewing our strategy. If you have a suggestion for us, or you have a kind of, oh, why can't you guys do it this way? Why can't you try this approach? Yeah, we are definitely open for any suggestion and any recommendation. So we really appreciate you for joining, the participants and our guests. Thanks so much for coming around for us. This is your second time here, and we believe 2024, when we reach out for any other session, you'll definitely be here. So thanks so much for everything that you do for the community. We appreciate that. People are shouting out in the chat saying thank you so much for joining. So with that, that's the end of our discussion today. See you next time. Bye bye for now.
Yeah, bye for now.
Bye.